Today I'll be looking at decoding percent encoded octets. This was one of the issues that was quite common in the recent CPI challenge that we hosted at INT4. So let's look into the details today. So what is percent encoding? It is also known as URL encoding. So what happens is you commonly use percent encoded to represent reserved characters as octets. These octets are hexadecimal digits with a percent prefix in front of it. So although it is generally used to represent reserved characters in a URL, it is actually not only limited to reserved characters. It also can be used for unreserved characters, although it is generally not recommended, or characters that are not in the ASCII character set. So some of the percent encoded octets are shown in this table. So we have the character ampersand, and then it is encoded as percent 26. And then also you have all these others and their corresponding percent encoded octet. And then another example is space. A space character is encoded as percent 20. So because of percent encoding, when you deal with a URL, you should actually implement decoding as a best practice when dealing with URL. So this allows you to get the actual characters that were represented as octets in a URL. So look at these two examples. So the first one, these two are part of a query string of a URL. The first one is employee ID equals 5, and it does not have percent encoding of this ampersand character. And then the next is expand customer. So this does not have percent encoding of the ampersand character, but you can actually also represent it as percent 26 to represent the same query string. So this is an example of it. So what we're gonna do is I'm going to show you sample HTTP calls which sends URL that has with percent encoded octets and without percent encoded octets on a solution that does not implement decoding. So this solution is actually from for the CPI challenge that we had recently. So this is a sample Groovy script, and you see it retrieves the string as the full query, but over here in the logic of the Groovy script, it does not implement any decoding. So this is this actually, you will see later on, this actually poses an issue because it will treat everything as it is without decoding. And then what happens is then the value is then used to form the old data filter criteria. So if you can see, for example, in this sample Groovy script, when a particular field is employee ID, it is actually just concatenated as it is, and then later on it concatenates the next field, the next query. So if I send a HTTP call with just a plain employee ID equals to 5, so this works fine. You can see employee ID equals to 5 here, employee ID equals to 5. So this gets all the results with employee ID equals to 5. So this works fine. So what if then I send employee ID equals to 5 and I add another parameter which string expand equals to customer. So let's see what happens on this one. Okay, this one fails because in the script it tries to concatenate, join this, and then it sends it to the old data adapter, and it fails because it is treating these two as these two as different parameters. So this is what I wanted to show you right now. We actually, this is like an attack. Instead of using an ampersand, I encode it as %26. So if I send this, just wait a while for the request to go through, and then we get the results. So now what happens here is, okay, it didn't fail, the call didn't fail, but if I search through employee ID, you can see, okay, the first result is 5. You can see, oh, it's getting employee ID 6, 4, 3. So it looks like the call was successful, and actually it's actually retrieving more data than actually we require. So it's like a hacking attack. So what is actually happening behind the scenes? So if you can see, I run trace on that. When you send %26 encoded as to represent the ampersand character, and your Groovy script did not decode it, it just pass it on to the OData adapter as it is. Then what happens if I run it through a proxy and I actually trace the call? The OData adapter actually just treats it, strips it off, and actually sends a get on the full entity set. That is why we are seeing the whole entity set, all the results are returned instead of just for employee 5. So actually, this shows that if you don't implement decoding of encoded octets, actually a hacking attack might occur if you do not write your script properly and all. So this is what happened. So how do you actually fix it then? What are the solutions to decode these encoded octets? There are two solutions that you can use in your script. One is based on java.net.uri class. There is a get query method. So this is from the sample solution that I've provided. So what you can do is you can create a new URI and then put on the query that was retrieved from the call, and then you do a URI.getQueryCall. So this actually decodes the query, and then it will be represented as the correct form. So the next one is also another choice that you have, java.net.url decoder. There is a decode method. So this was by some of the other participants that sent in their solution. So you can do a URL decode, then you pass in the string that you want to decode, and then you pass in the encoding. So this is, although it is simpler, but actually if you read the documents for this, it is actually mainly used for MIME format application /x www form URL encoded. So this is actually the specific MIME format that it is used for, but it is actually possible to use this. So there you are. Today you are able to learn something about encoded octets. What happens if you don't do it? There's potential security issues that would occur, and what are the decoding solutions. Thank you for watching this video, and bye bye.